So now we're going to take a look at Module 2, where we're going to explore some of the relational data services in Azure. So we're going to take a look at things like SQL databases, PostgreSQL, MySQL, MariaDB, and we're going to look at how to provision and deploy relational data in Azure, as well as how we can query relational data in Azure. So let's get started with Module 2. Lesson 1, Explore Relational Data Offerings in Azure. So what are some of the Azure Relational Data Services? Well, we've got SQL Server on Azure Virtual Machines, we've got Azure SQL Managed Instances, and Azure SQL Database. So Azure offers a range of options for running a database management system in the cloud. For example, you can migrate your on-premises systems to a collection of Azure virtual machines. This approach still requires you to manage your database management systems under the hood. Alternatively, you can take advantage of the various Azure Relational Data Services available. So these data services actually manage the database management system layer for you, which means you can really just concentrate on the data that will be consumed by your applications. Now, before we dive into the Azure Data Services a little bit more, let's just talk about some of the common terminologies that we might be using, as well as the different ways that you can host a relational database in Azure. So infrastructure as a service, or IaaS, generally describes services where Azure enables you to create a virtual infrastructure in the cloud that mirrors the way that an on-premises data center might work. So you can create a set of virtual machines, you can connect them together using a virtual network, and you can add a range of virtual devices to the network. So you still need to be responsible for installing and configuring the software, such as the database management systems on these virtual machines. So in a lot of ways, this approach is quite similar to the way that you would typically run your database management systems on premises within your organization, except you don't have to buy or maintain hardware anymore. Platform as a service, or PaaS, are services where rather than creating a virtual infrastructure and installing and managing the database software yourself, a PaaS solution does this for you. So you specify the resources that you require based on how large you think your databases will need to be, how many users will be using them, the performance requirements that you need, and Azure automatically creates the virtual machines, networks, and other devices for you. You can also scale up and down, increase or decrease the number of resources quite quickly as well. So as the volume of data or the amount of work that you need to do grows, you can easily scale according to the growth of your workload. And Azure will automatically handle the scaling for you so that you don't have to go and manually add or remove virtual machines or perform any other types of configuration. Now, Azure Data Services generally fall into the PaaS category. So these services are essentially a series of database management systems managed by Microsoft in the cloud in Azure. So with each of these data services, Microsoft takes care of the configuration, the day-to-day management, software updates and security of the databases that it hosts, as well as all the other administrative tasks. So all you have to do is really create the database, and then they will be managed and looked after by the Azure Data Service. Now, the most well-known one is the Azure SQL Database. Others include Azure Database for MySQL, for MariaDB, and PostgreSQL. Now, while the Azure Data Services helps you reduce the amount of time that you need to invest into administrating a database management system, these services also come with some limitations in terms of the custom administration tasks that you can perform to them. So, for example, some database management systems allows you to install custom software into a database, or you can run scripts as part of the database operation. Now, in PaaS, this might not be supported because allowing these scripts to run in the database means we have to expose the security of the data servers. So that's going to expose the data servers to potentially some security vulnerabilities and concerns. So you must be prepared to work with some of these restrictions in mind when you're working with Azure Data Services. Now, apart from reducing the administrative workload, Azure Data Services ensures that your databases are highly available at least 99.99% of the time. What that means is that they're guaranteed to be up and running at least 99.99% of the time. Although Azure Data Services is actually much cheaper in comparison to the IaaS option, there are still costs associated to running an Azure PaaS data service, because there is a base price which covers the underlying infrastructure, licensing, administrative charges, and additionally, Azure Data Services are designed to be always on. What that means is you can't stop it running for a set period of time and restart it again later, unlike Azure Virtual Machines. So you have no direct control over the platform on which these data services run on. If you do need more control than what the Azure Data Services offers you, you can install your database management system to an Azure virtual machine. Now, Microsoft SQL Server has been traditionally quite a popular relational database management system. Has a long-running history with a lot of features that provide database management systems to organizations of all shapes and sizes. And so in the past, a lot of organizations have been running SQL Server on premises. But a lot of organizations these days are actually looking at shifting this operation to the cloud. And so there are a couple of ways that you can run SQL Server in Azure. So SQL Server on an Azure virtual machine enables you to run a full version of SQL Server in the cloud without having to manage any on-premises hardware. So this is that IaaS approach. You can use SQL Server in an Azure virtual machine to develop and test your traditional SQL Server applications. With an Azure virtual machine, you have the full administrative rights over the database management system and the operating system. So it's a perfect choice if your organization already has IT resources to maintain and manage virtual machines. And so what that means is you can create very rapid development and testing scenarios using Azure virtual machines without having to buy on-premises SQL Server hardware for non-production workloads. You can also lift and shift existing applications that require very fast migration to the cloud with minimal changes or virtually no changes at all. And you can also scale up on the Azure platform where your SQL Server is running by allocating more memory, more CPU power, more disk space on the Azure virtual machine as you need it. So you can quickly resize an Azure virtual machine without the requirement of having to reinstall the software that is running inside those virtual machines. So you have three options to deploy a SQL Server to an Azure virtual machine. There are some pre-installed SQL Server on Windows and Linux virtual machines in Azure, which you can access through the marketplace. You can also install your own SQL Server to an Azure virtual machine. You can lift and shift your on-premises SQL databases using Azure Migrate and Azure Site Recovery. How SQL Server on Azure Virtual Machine might benefit you is you've got greater access to licensing and additional flexibility in the cloud. Some of the backups can be automated and you can apply security updates to your databases as well. You can also manage your SQL servers through the Azure Virtual Machine as long as you can connect to your virtual machines. Now, in terms of sizes, storage, and performance, you get to choose between memory or storage options to optimize your databases for better performance. You can store your data and logs on premium managed disk storage. You can use ultra disk storage for low latency access, and your temporary database can actually be stored on local solid-state drive disks. In terms of network and security, you can integrate your Azure Virtual Networks with your on-premises network so that your SQL Server databases can actually communicate back on premises with the applications that might still be on premises. You can access advanced data security services in the cloud. And in terms of HANDR, which means high availability and disaster recovery, you can configure high availability for your Azure virtual machines using either availability sets or availability zones. You can also use some of the redundancy options to configure disaster recovery for your storage. You can easily make backups of your databases using some of the Azure backup services. And with HANDR configured, you can easily fail over when one of your or more databases go down. Now, if you don't want to incur the management overhead costs associated with running a SQL Server on an Azure virtual machine, you can use Azure SQL Database. So Azure SQL Database is a PaaS offering for Microsoft. You create a managed database server in the cloud and then deploy your databases to the server. So when you use Azure SQL Database, you actually need to create an Azure SQL Database server first. So this SQL Database server is actually a logical server that acts as a central administrative point for a single, multiple or pool databases, logins, firewall rules, auditing rules, threat detection policies, and failover groups. So Azure SQL Database is available in a couple of options. You can have a single database, elastic pool, and managed instance. Now, Azure SQL Database gives you the best option for low cost with minimal administration, but it's not fully compatible with some of the on-premises SQL Server. So typically, Azure SQL Database is considered when building out new cloud projects where the application design can accommodate to these kind of changes to your database tier. So Azure SQL Database, it's often used for modern cloud applications that need to use the latest stable SQL Server features, applications that require high availability, and systems that have a variable load. So if your database server needs to scale up and down very, very quickly, Azure SQL Database is able to support that. Now you might be wondering, what else does Azure SQL Database take care of? Well, Azure SQL Database automatically updates and patches the SQL Server software for you and ensures that you're always running on the latest and most secure version of SQL Server. Azure SQL Database can also scale your resources up and down depending on your requirements without you having to perform any manual interventions. Azure SQL Database also provides high availability guarantees to ensure that your databases are available at least 99.99% of the time. Azure SQL Database also supports point-in-time restore, which means you can recover your database to some particular state or point of time in the past. You can also choose to replicate your Azure SQL databases to any one of the 60 plus global Azure regions across the world to provide that additional assurance and disaster recovery. Azure SQL Database also comes with advanced threat protection. So advanced threat protection provides advanced security capabilities like vulnerability assessments to help detect and remediate potential security problems with your databases. It also can be used to detect anomaly activities. So that could indicate unusual or potentially harmful attempts to access or exploit your databases. With advanced threat protection, you can also use it to continuously monitor your databases for suspicious activities and provide immediate alerts on any potential security incidents like SQL injection attacks. And the alerts can also provide details on the suspicious activities as well as recommendations on how to investigate and mitigate those threats. You can also audit your database events and write audit logs to an Azure storage account. So auditing can help you maintain regulatory compliance, understand database activity, and gain insight into discrepancies and anomalies that might indicate potential security violations. So Azure SQL Database can also help secure your data by providing encryption. So for data in motion, it uses the transport layer security. For data at rest, it uses transparent data encryption. And for data in use, it uses always encrypted. So you can be sure that your data is always safe and protected. Now, a business might also want to eliminate the management overhead costs as much as possible from having to administer databases and server, but because of some of the limitations of Azure SQL databases, Azure SQL Database might not be the best option for them. And so in these kind of situations, Azure SQL Database Managed Instance is an alternative to consider. So Managed Instance effectively allows you to run a fully controllable instance of SQL Server in the cloud. So you can install multiple databases on the same managed instance. You have complete control over this instance, same as you would on premises. The managed instance service automates things like backup, software patching, database monitoring, and other general tasks that you would need to do on premises, but you still have full control over the security and resource allocation for your databases. So managed instance depend on a lot of other different Azure services like Azure Storage for backups, Azure Event Hubs for telemetry, Azure Active Directory for authentication, Azure Key Vault for transparent data encryption, and a couple more other Azure services that provide security and supportability features. So the managed instance is essentially a setup of all these services that has already been done for you to really help relieve some of those administrative efforts so that you don't have to do it. Now, all communications are encrypted and it uses certificates. So to check the trustworthiness of a communicating party, managed instances constantly verify the certificates through a certificate revocation list. So if the certificates are revoked, the managed instance will close the connection to protect the data. Now, managed instances has near 100% capability with SQL Server Enterprise Edition running on premises. So if you want to lift and shift your on-premises SQL Server to the cloud without incurring those management overhead costs of running a SQL Server on an Azure virtual machine, then you should really consider using Azure SQL Database Managed Instance. Now, Azure SQL Database Managed Instance also provides features that's not available in Azure SQL Database. So if your system uses features such as linked servers or a service broker, which is a message processing system that can be used to distribute work across the servers, or a database mail, which enables your database to send email messages to users, you should also consider using Azure SQL Database Managed Instance. If you want to check the compatibility with your existing on-premises SQL Server, you can install the Data Migration Assistant tool. And this tool will help analyze your databases on premises and report any issues that could block this migration to a managed instance. Now, when it comes to both Azure SQL Database Managed Instances and Azure SQL Database, typically there are two options. There's what's called the single and the pool option. So a single database or a single instance, this option allows you to quickly set up and run a single SQL database server, and you can create and run a database server in Azure and access your database through the server. So Microsoft will manage the server so that all you have to do is configure the databases, create those tables, populate them with data, and you can scale the database with more storage or memory or processing power, CPU, if you need it. By default, the resources are pre-allocated, and so you're charged per hour for the resources you requested. You can also specify a serverless configuration. So with the serverless configuration, Microsoft will create the server for you, but this might actually be shared with other databases belonging to other Azure users. However, Microsoft will ensure the privacy of your database. So although the resources are shared amongst other users, your data inside your database is still kept private and only accessible to you. So your database can also automatically scale up and down with the resources allocated as you need it. Now with the elastic pool option, this is similar to that single database option, except by default, multiple databases can share the same resources like memory, storage, and processing power. And these resources are referred to as a pool. So you can create the pool and only your databases can use this pool. So it's not shared amongst other Azure users. And this model is actually quite useful if you have databases with resource requirements that can change or vary over time, and it can help you reduce costs. So for example, you might be running a payroll database that might require a lot of CPU power at the end of the month as you handle this payroll processing. But at other times, when it's not handling those payroll processing, the database might be less active. And so you can have another database being used to run other operations using those kind of resources. Now, your payroll database during that payroll processing period might become active for a couple of days to process those payrolls, and at other times it might not need it. And so with Elastic Pool, what this allows you to do is essentially scale the resources Azure databases needs them and release the resources when the processing is complete and allocated to other databases that might need it. Now, as well as Azure SQL Database, Azure Data Services also offers other database services for some of the other relational databases in the market. For example, PostgreSQL, MySQL, and MariaDB. The primary reason for these services is really to enable organizations that are already running PostgreSQL, MySQL, or MariaDB to move to Azure quite quickly without having to make a lot of changes to their applications. So PostgreSQL, MariaDB, and MySQL, they're all relational database management systems, each with their own special tailored features. So PostgreSQL is a hybrid relational object database. You can store data in relational tables, but a PostgreSQL database can also enable you to store custom data types with their own non-relational properties. So the database management system, it's extensible, so you can add code modules to the database, which can be run by queries. Another key feature of PostgreSQL is it's got the ability to store and manipulate geometric data. So these are things like lines, circles, polygons. PostgreSQL has its own querying language called PostgreSQL, and this language is sort of a variant of the standard relational query language SQL. And there's features inside PostgreSQL that allows you to write your own store procedure and run them inside a PostgreSQL database. Now, MySQL started off as a simple to use open source database management system. And it comes in a couple of editions. So there's the Community Edition, Standard Edition, and Enterprise Edition. The Community Edition is free, and that's why it's been sort of a popular database management system for a lot of web applications. And under the hood, it runs on Linux. So there are some versions available for Windows as well. Now, the Standard Edition offers higher performance and uses a different technology stack for storing data. The Enterprise Edition provides a more comprehensive set of tools and features, including enhanced security, availability, and scalability. So the Standard and the Enterprise Editions are generally the ones that are used by commercial organizations because those versions are not free. Now, MariaDB is a newer database management system that's been created by the original developers of MySQL, actually. So the database engine has since been rewritten and optimized to improve performance. So MariaDB offers compatibility with Oracle Database, which is another popular commercial database management system. And one notable feature of MariaDB is it has inbuilt support for temporal data. So a table can actually hold several versions of data, which enables an application to query data as it appears at some point in the past. So Azure MySQL Database is based on the MySQL Community Edition. The Azure MySQL Database service includes high availability at no additional cost and scalability as you require it. So you only pay for what you use, and backups are automated with point-in-time restores up to 35 days in the past. The server also provides connection security, which enforces firewalls and optionally requires SSL connections. Many server parameters also enable you to configure the server settings so that you can enable lock modes, maximum number of connections, and timeouts. Now, the Azure MySQL Database provides a global database system that scales up to large databases without the need for you to manage any hardware, any network components, virtual servers, patch any software, and any of those things. So there are some operations in Azure MySQL Database that are not available. And these are usually because of that security component. So these limitations are usually if you want to do any customization to your Azure MySQL database, which could lead to potential security vulnerabilities. Benefits for MariaDB is almost exactly the same as MySQL. Now, if you prefer Azure PostgreSQL, you can choose Azure Database for PostgreSQL. So this service provides the same availability and performance, scaling, security, and administrative benefits as the Azure MySQL service. Again, some of the features that you might find within on-premises PostgreSQL database are not available in the Azure PostgreSQL database service. So these features are mainly concerned with extensions that users can add to a database to perform specialized tasks, such as writing store procedures in programming languages other than PGSQL, and interacting directly with the operating system. Now, Azure PostgreSQL has two deployment options you can choose from. So you can have a single server or hyperscale. So with single server, the single server deployment option for PostgreSQL provides similar benefits as the Azure MySQL database. You choose from 3 pricing tiers, so basic, general purpose, and memory optimized. Each of these tiers supports different numbers of CPU, memory, and storage sizes, so you can select the one that matches your workload requirements. Now, the hyperscale option is a deployment option that scales queries across multiple server nodes to support large database loads. So your database is split across multiple nodes. These data is split into chunks based on the value of a partition key or a sharding key. So you should consider using the hyperscale option for very large databases with PostgreSQL deployments in Azure. Some of the benefits for Azure PostgreSQL database is that it's highly available and it contains built-in failure detection and failover mechanisms. Now, users of PostgreSQL might be familiar with the PG admin tool, which is a tool that is used to manage and monitor PostgreSQL database. And so you can continue to use this tool to connect to your Azure PostgreSQL database as well. Lesson 2, exploring, provisioning, and deploying relational database offerings in Azure. Now, what exactly is provisioning? Well, when a user specifies that they want to provision something, they need to specify the provisioning parameters, such as the type of servers, storage, memory, and compute power. These provisioning parameters are then sent to Azure to provision the service, and then Azure allocates the necessary resources to create the service. Now, once the service has finished provisioning, then the service is actually ready to use and the user can start to consume the service. So the process for provisioning Azure SQL Database is quite similar across Azure SQL Database, Azure MySQL Database, Azure PostgreSQL Database, and Azure MariaDB Database. So you have to provide a couple of the provisioning parameters, and we usually start with the Basics tab. So in the Basics tab, we specify a couple of the settings like subscription. So an Azure subscription is essentially a billing account attached to your Azure account. We also have to specify the resource group. So you can either put your database in an existing resource group or create a new one. A resource group is just a logical container for your Azure resources. You also need to specify the server name. So each database server must have a unique name that hasn't been used by someone else. The name typically needs to be between 3 to 31 characters long and usually contains only lowercase letters, digits, and hyphens. You also can choose to specify the data source. And so if you choose none, it means you're creating a brand new database, or if you select backup, you are creating a server from an existing database. In the location, you need to choose the region to deploy that database server and database to. And so typically you would choose a region that is closest to you or closest to your user. And an Azure region is essentially one or more Azure data centers in the geolocation where your resources are being deployed and hosted out of. In the compute and storage parts, you need to specify the compute, storage, and backup configurations for your new server. And typically, this is bundled up into what's called DTUs, or database transaction units. And for the pricing tier, there's typically 3 pricing tiers you can choose from. So the basic pricing tier is generally for those that require light compute and very light input-output performance, and they're typically reserved for very small-scale development, testing users. The general-purpose pricing tier, so this pricing tier is for business workloads that require balanced compute and memory with scalable I/O throughput. So examples include servers for hosting web and mobile apps and other enterprise applications. And then there's the memory optimized pricing tier. Now this tier supports high performance database workloads that require in-memory performance for faster transaction processing and higher concurrency. So some examples might be servers that processes real-time data and high-performance transactions or analytical apps. So you can fine-tune the resources for each of the selected tiers. You can also scale it up if you need to later on. Typically, when you provision data services, you also need to give it some credentials. And so this involves an admin username and a password. So with this, we create a sign-in account where you can use it to connect to your server. Now, the admin sign-in name can't contain words like admin, administrator, root, guest, or public. So you should pick an admin username that has some meaning for your data server. And there are some limitations to the password part as well. So you need to choose, the password needs to contain characters that's between 8 to 128 characters in length. It needs to have characters from a lowercase, uppercase letter. It needs to contain a digit and some non-alphanumeric character as well. And after you've specified all these settings, you can then go and create, which will then provision the data server for you. There are also additional settings and network connectivity settings that you can specify as well upon provisioning your databases, but you can also go and modify and update these settings once you've provisioned your databases and your data servers. Now, Azure SQL Database communicates over port 1433. So if you're trying to connect from within the corporate network, sometimes outbound traffic over port 1433 might not be allowed by your network's firewall. So if that's the case, you won't be actually able to connect to your Azure SQL Database server unless your IT department opens up port 1433. Now, the default connectivity for Azure Relational Data Services is actually disabled across the world. So if you need to connect the service to the service from an on-premises computer or machine, in the firewall section, you need to actually add the IP address range of the computer or machine trying to connect to the Azure Data Service. Now, a firewall rule of 0.0.0.0 enables all Azure services to pass through the server level firewall rule. So if you wanted to open up your data service to the world, you can also specify this range to be between 0.0.0.0 to 255.255.255.255. However, keep in mind that you shouldn't actually do this for any production workloads and only allow access for the machines and applications that needs to access your databases. Otherwise, you'll be exposing yourself to a lot of security vulnerabilities on the network. Now, if we take a look at this diagram here, so we've got a client connecting to the database gateway, which has a public IP address and is listing on port 1433. Now, this gateway, depending on what connection policy has been specified on this gateway, will either redirect or proxy the traffic to the right database tier in the backend. And so then inside the database cluster tier, the traffic is then forwarded to the appropriate database. You can specify 3 types of server connection policies. So there is the redirect connection policy, which is the recommended one. The redirect one will allow a client to establish connections directly to the node that's hosting the database, which means there is lower latency and higher throughput. Now, for connections to use this kind of connection policy mode, the client needs to allow outbound communication from the client to all Azure SQL IP addresses in the region on ports in the range of 11000 to 11999. We can also use service tags for SQL to make this easier to manage. And so service tags is essentially a group of IP address ranges that's specific to a particular Azure product or service. Now, it also needs to allow outbound communication from the client to the Azure SQL Database Gateway IP address on port 1433. The other connection policy mode that you can choose from is the proxy mode. So in this mode, all connections are proxied via the Azure SQL Database Gateway, which means there is a bit more latency and reduced throughput. And for connections to use this mode, the client needs to allow outbound communication from the client to the Azure SQL Database Gateway IP address on port 1433. And the third connection policy mode is the default one. So this is the connection policy that's established by default unless you explicitly alter the connection policy to either proxy or redirect. Now, the default policy will redirect for all client connections originating inside of Azure. So say, for example, if you're trying to connect to your Azure SQL database from an Azure virtual machine, and it will proxy all client connections originating outside of the Azure network. So for example, if you're trying to connect to your Azure SQL database from an on-premises network. So we highly recommend using the redirect connection policy over the proxy connection policy for that lower latency and higher throughput. But if you need to meet additional requirements for allowing network traffic, you can also use the proxy connection mode to do so. If the client is an Azure virtual machine, you can accomplish this using network security groups or NSGs using service tags as well. So if the client is connecting from within a on-premises workstation, then you may need to work with your network admin to allow network traffic through the corporate firewall. If we're trying to connect from within Azure, your connections need to have a connection policy of redirect by default. So a policy of redirect means that after the TCP session is established to the Azure SQL Database, the client session is then redirected to the right database tier with a change to the direction to the destination virtual IP from that of the Azure SQL Database gateway to that of the cluster. And then after that, subsequent packet flows will be directed to the cluster, bypassing the Azure Database gateway. Now, if we're connecting from outside of Azure, your connections will have the proxy connection policy by default. So a policy of a proxy means the TCP connection, once the TCP connection is established via the Azure SQL Database gateway, all the subsequent packets will flow via the gateway.
So when it comes to network security for SQL databases, we can configure a couple of things like which services to allow to access our SQL database. So we can do that through firewall rules or setting up virtual network rules or using private link. So let's say we wanted to lock down the traffic to our Azure SQL databases and block off public internet access to these SQL databases. So using private endpoint, we can block off public internet access to our Azure SQL database so that the only connection it has is a private endpoint, which is part of the Azure Virtual Network that Azure SQL Database talks to. So with Azure Private Endpoint, this is a network interface that allows you to privately and securely connect to Azure services through a private link. So private endpoint uses a private IP address from your virtual network so that it effectively brings that service into your virtual network. Now we can also use things like VPN gateway or ExpressRoute to connect our on-premises environment to our Azure Virtual Network. And then we can block off all the public internet access to our Azure SQL database. So this setup allows our on-premises environment to connect to our Azure SQL databases running in Azure over that private IP address space. We can also use VNet pairing to pair multiple virtual networks together so that essentially we can treat them like one, and so that resources can communicate with one another over that private IP address space as well.
With Azure Active Directory authentication, you can centrally manage the identities of database users and other Microsoft services in one central location. So central ID management provides a single place to manage database users and simplify permission management. So you can use these identities and configure access to your relational data services. Some of the benefits of doing so is that it provides an alternative to SQL Server authentication. It allows for password rotation in a single place. Customers can also manage database permissions using external Azure AD groups. You can also eliminate storing passwords by enabling integrated Windows authentication. Azure AD authentication uses contain database users to authenticate identities at the database level. Azure Active Directory also supports token-based authentication for applications connecting to SQL Database and SQL Managed Instances. And Azure Active Directory also supports multi-factor authentication, which means you can include strong authentication from a bunch of verification options like phone calls, text messages, smart cards, pins, or a mobile app notification. You can also authenticate users connecting to Azure PostgreSQL Database or Azure MySQL Database through Azure Active Directory as well. So Azure Active Directory enables you to specify who and what can access your resources, and these access controls will define what a user or an application can do with your resources once they've been authenticated. So access management for cloud resources is a critical function for any organization that is using the cloud. So Azure Role-Based Access Control, or Azure RBAC, helps you manage who has access to Azure resources and what they can do with those resources. So for example, using RBAC, you could allow a user to manage virtual machines in a subscription and allow another user to manage virtual networks, or you could allow a user to be the database administrator so that they can manage SQL databases in a subscription and allow another user to manage all resources in the resource group, like virtual machines, websites, and subnets. And you could also use it to allow an application to access all the resources in the resource group. So you can control access through resources using Azure RBAC by creating role assignments. And so a role assignment consists of 3 elements. It consists of a security principal, role definition, and a scope. So a security principal is an object that represents a user, a group, a service principal, or a manager identity that is used to request access to a particular Azure resource. A role definition, often just called a role, is a collection of permissions. And a role definition lists the operations that can be performed, such as read, write, delete. Roles can be given quite high-level names like owner or virtual machine reader. Azure includes a couple of built-in roles that you can use. So the owner role has full access to all the resources, including the right to delegate access to others. The contributor role allows you to create and manage all types of Azure resources, but you can't grant access to others. The reader role will allow you to view existing Azure resources, but you can't modify, update, or delete any resources. And the user access administrator role allows you to manage user access to your Azure resources. Now, a scope lists the set of resources that the access applies to. So when you assign a role, you can further limit the actions allowed by defining a scope. This is quite helpful, for example, if you want to make someone a website contributor, but only for one resource group. So similar to Azure SQL databases, you can also replicate data for Azure PostgreSQL Database or Azure MySQL Database to read-only servers. So Azure PostgreSQL Database supports replication from the master server up to 5 replicas. So replicas are updated asynchronously with PostgreSQL Engine's native replication technology. The read replicas help to improve the performance and scale of read-intensive workloads. So read workloads can be isolated to the replicas, while the write workloads can be directed to the master. Common scenario where you might use this is if you've got analytical workloads that uses the read replica as the data source for reporting. Because the replicas are read-only, they don't directly reduce the burden of write operations on the master. Now, this kind of replica feature isn't targeted for write-intensive workloads. So replicas are new service that you need to manage, similar to regular Azure databases. So for each replica, you're actually billed for the provision compute in virtual cores and storage in gigabytes per month. Now for Azure MySQL Database, similar to the Azure PostgreSQL Database, you can again create up to 5 read replicas for your MySQL database. And this feature enables you to geo-replicate data across regions and distributes the overheads associated with read-intensive workloads. So replication is asynchronous from the master server, so there might be some lag between when records are written to at the master to when it becomes available across all the replicas. Just remember though, re-replication isn't intended to support write-heavy workloads.